Hello, grade nines. Hope you're doing well. And today we're going to talk about or go over topic 7.1, which is multiplying monomials and also dividing monomials. I guess I first need to apologize for my penmanship before it happens because I'm nowhere near as neat as Mrs. Strobel or Mrs. Babe when I write. So hopefully you can read this when it's all said and done. The multiplication of monomials is fairly straightforward. What we're going to do in order to multiply monomials is we're going to, again, multiply the coefficients, which are the numbers attached to the variables. So in this first example A, the coefficients are 30 and 4. We multiply those together. And then the next step is we just multiply the variables, which are the letters. And if the variables are the same, we will use some exponent laws to multiply those. So let's do these first four examples and see how we do. So in A, 30x times 4y, I'm taking 30 times 4, so I multiply the coefficients together, and then I multiply the variables, x times y. And if I put that all together, 30 times 4 is 120, and x times y is just x, y. And that's as tough as it gets. Example B, same process. We've got monomial 11a times the monomial 2b. I multiply the coefficients together, so I take 11 times 2, and I take a times b, or I multiply the variables. And if I write that out, that becomes 22ab. The second step here isn't necessary. You don't have to show that you're multiplying all those together. Just so you understand that you're just multiplying the coefficients together and multiplying the variables. C, same process. Again, I'm taking this monomial 3x squared times 5x cubed. I multiply the coefficients, 3 times 5. That gives me 15. And x squared times x cubed. This is where I use exponent laws. Again, we learned earlier in the year, if I'm taking x squared times x cubed, this is the product of powers exponent law. And the rule is when I multiply and the bases are the same, I keep my base and I add my exponent. So the 2 plus 3, that becomes 5. So this is 15 x to the fifth. I take 3 times 5 to get 15, and x squared times x cubed is x to the fifth. Example D, negative 5 times 3.2. Oh boy, that sounds like negative 16. And I have to get rid of that thing, and I don't know why that appeared. Give me 1 second here. And I'll get rid of it. Perfect, kind of. Let's get rid of the E. There. All right, so negative 5 times 3.2 is negative 16. And x, there's not another x in the 3.2, so that just stays in. So this product is negative 16x. The only other thing that they may do to you, or type of question they may ask you, is they try and put it in an application type question. This is asking you to find the area of a rectangle, and it gives us dimensions of length of 4.3x and a width of 2x. Again, to find the area of a rectangle, it's just length times width. So all I'm doing is I'm taking 4.3x, let's put brackets around that, times 2x, and I just apply the same process. I'm going to multiply the coefficients, 4.3 times 2, which is 8.6, and x times x, which is x squared. So the area of this rectangle is 8.6 x squared. And that is how to multiply monomials. Division of monomials is much the same, except instead of multiplying the coefficients, we are now dividing the coefficients. And instead of multiplying the variables, we are now dividing the variables. And again, if variables are the same, we have to use some exponent laws from time to time. So in this one here, in A, again, all I'm doing is I'm dividing the coefficients. So I have negative 10 divided by 2, and I have x squared divided by x. I'm dividing the coefficients, dividing the variables. Again, writing this step out isn't necessary, but if you want to, you can. So negative 10 divided by 2 is negative 5, and x squared divided by x, again, this is exponent laws. This is quotient of powers. The bases are the same. The rule is I keep my base and I subtract my exponents. Again, this x has an exponent of 1 on it. We just don't usually write it, but it does exist. So I keep my base of x, and I subtract my exponents. X squared divided by x, or x to the first, is just x. So this becomes negative 5x. B, same process. Divide the coefficients. 8 divided by 4 is 2. Now I have x divided by x. That is, again, x to the first divided by x to the first. I keep my base, I subtract my exponents, which is x to the 0, which is equal to 1. So basically these x's are just canceling each other out. And I'm left with a y, so the answer to this one is 2y. And that's dividing monomials. We'll do a few at the bottom here, and actually if you want, you might want to just pause this, divide these 5, see what you come up with, and I'll go through the answers, and you can just check to see if you've done them correctly, and hopefully I do. So A, 12xy divided by 3y, again I divide the coefficients, 12 divided by 3 is 4. X, there is nothing to divide the x by, so it just stays as x, and y divided by y, they cancel each other out, and so my answer should be just 4x. B, negative 14 divided by negative 2. Again, be careful, that's integers. Negative divided by negative is positive, so that is positive 7. And x squared divided by x, again, keep your bases, subtract your exponents, that just becomes x, or x to the first. In this one here, A, I'll put it right there. I have 18x squared divided by 3x, so I take 18 divided by 3, which is 6, and x squared divided by x, again, is just x. In example B, I have 14y divided by negative 2. Now, they may write the division statement in that instead of kind of fraction form. If they write it like that, if you don't like doing that, we can go 14y divided by negative 2. That means exactly the same thing. 14 divided by negative 2 is negative 7, and there's nothing to divide the y by, so it stays in. So the answer to that one is negative 7y. Example C, I have negative 18.6 mn divided by negative 3n. When I divide negative 18.6 divided by negative 3, that to me, I believe, should be positive 6.2. And there is no m to divide anything by, so it stays in. And n divided by n is n to the 0, or 1. They technically just cancel each other out. So the answer to C is 6.2 m. Again, the other type of question that you might see is if they put in an application type question. I'm just going to grab this and move it down here a little bit so I have some, I don't want that. Grab this, move it down so I have a little bit of room to work. And in this one, they're giving me the area of a rectangle is 24x squared y, and they're giving me the width as 3x, and they're asking me to find my missing dimension, which is the length. Again, area of a rectangle is length times width. And if I put everything in here, again, the area is 24x squared y, and that is whatever the length is times 3x. So I have to figure out this missing piece of information. If you're given the area and either the length or the width, to find the missing dimension, all we do is we take the area, 24x squared y, and we divide it by In this case, it's the width, which is 3x, and that will give us the missing dimension. So 24 divided by 3 is 8. X squared divided by x is x. And I have a y that's not getting divided by anything, so it stays in. So my missing dimension, or my length in this case, is 8xy. You can always check this, because you know that the length times the width should be 24x squared y. So if you take 3x times 8xy, that should give me the area. 3 times 8 is 24. X times x is x squared, and then y is just staying in. So that is the area, 24x squared y. So that is the correct missing dimension. Hope that made sense. Give the questions a try, and if you have any questions or difficulties, do get a hold of one of us, and we'd be happy to help.